Dobry din всем. Меня зовут Clemens Dannheim из Luxoft, München. Извините, я не могу подальше говорить по-русски, потому что мой язык очень мало. So I switch to English. So I'm very glad today to be here. Thank you for your invitation to allow us to talk about cybersecurity in the context of new mobility. As we all know, mobility is under change in the moment, and we do a lot of research, current development for our OEMs, and so there is really a wide range to be addressed in this context. Short overview about what we do. Industry challenges, autonomous assisted driving. I think it's everybody's interest in the moment to share and to get some more information, connected mobility, and last not least, what are the approaches we have to take for cybersecurity within mobility. Some references to teleoperation, as fallback solutions for autonomous drive and for automated shared economy, and infrastructure-based driving. Some words to Luxoft. Luxoft has Russian roots. I think it was founded here somewhere in Moscow. So far, the company is placed and located in Switzerland, Zurich. And recently, DXC, I think a US company, bought Luxoft. So we are now a 140,000 people company. And there are three pillars within Luxoft. We are working on automotive activities, so my responsibility is business development in this context. Future assisted mobility. As we all know, mobility is affecting not only our day-to-day business life, or at least our right to work and to do our private issues. I think it's affecting personal digital lifestyle. It's connected to smart home. We are, in front of electrification. I think in China, it's a quite interesting example. There is a high degree of electrification already visible. We are in front of sharing economy, car sharing, shared taxis, ride hailing, and last not least, the full automation of driving. So in the future might be, in a couple of years, we will see autonomous cars on the roads. And if we need a taxi, there is a taxi will arrive without any driver in it. And we just enter the car and drive to our destination. I think the key industry challenges here are, they are not only looking for mechanical engineering. I think for OEMs, for car manufacturers, we have really the challenge to deal with software. I am from Munich, and as probably everybody knows, Munich is well famous for BMW. And I think they invested really millions of euros into the changes they have to obey. OEM gets a car manufacturer, software company. So the next thing they have to deal with to invest a lot into autonomy, driving assistance functionality, connected mobility. This leads to personal and digital lifestyle, and also digitalization of customer relationships, big data, making use of data to combine what is analyzed and so on. And this is, I think, the challenge. As an example, if we are looking back, the car in the former times was an isolated item. The vehicle was, I think, delivered, a software version was given, technology was given, there was no connection at all. Today, life changes. We are trying to do a lot of standardizations, to think about autos, our operating system platform development for vehicles in the context of in-vehicle entertainment and so on. We are at least open now for further collaborations, and here, for example, one combination, you know, we have recently decided to work on a joint venture together is with Luxoft and LGE on a WebOS for vehicles, so that at least for the in-vehicle infotainment systems, there will be a probable standardization so that further interactions on vehicles in terms of navigation, infotainment, streaming services and so on can be done on standardized platforms. Another nice example we implemented for our customer in Stuttgart, it's the MBUX, the Daimler user experience. This is made at least at the desktop from Luxoft, and here it also demonstrates how things are emerging and are being integrated into a consolidated platform. If we look, for example, to a well-known operating system provider, we talk about Microsoft. Microsoft and Luxoft has joined an alliance, and we are a partner now for the Microsoft Connected Vehicle Platform. In this context, we will make use of business directions, digital product strategies, customer voice and values, and so on, development and interaction in the middle, connectivity, telematics, onboard, HPC platform, consolidation towards only a few ECUs within a car, mega ECUs, then having a lot of different small control units in the car distributed, supported by a standardized platform, operating system platform, and for business execution, to provide to the to the user at least billing, payment, UBI insurance systems, integrated technology to support your driving, and this all under the hood of such a unified operating system platform. Coming to autonomous vehicle, as you probably, or as probably everybody knows here from scientific disciplines, to drive a car autonomously, we have to look at sensors, to conduct the vision of the car, the vehicle. We have to look at vehicle platforms, to sensor fusion models, autonomy functions, and integration of all the stuff. And here, as a middle layer, we have to think about cybersecurity. Can you imagine in the near future, the car does a localization and a mapping into a map, and what happens if phantom objects are somehow created from the outside and the car gets an object injected and it does not exist in real life, and the surrounding or the underlying technology does divert, for example, to drive to the right side to avoid an obstacle, and suddenly a damage is caused by such a attack. Here we have really, and this is I think also quite interesting topic for research, to go together towards AD and artificial intelligence, machine learning, how to secure such systems, so that knowledge bases necessary, to conduct autonomous drive are at least safe and secure. And this is really something we could share with you, with research, how to do the next steps together to make this safe. There is a short video. I hope I can start it here. Oops. Can somebody from operations start the video? Thank you. This is one of our research cars, and here, you know, one essential to do autonomous drive is to have a high accurate map, dynamic map, localization, perception on sensor basis. You know, the radar, the eyes of the cars are you know, based on laser scanners, radar scanners and camera systems. And here we can see the illustration how the car recognizes his environments. And this is the full scope, you know, the lane model. And, you know, to instantly communicate with your surrounding environment. The vehicle has the car-to-car communication and the three major components: localization mapping, trajectory planning and strategy, and the driving control. And this is an illustration how the car is driven autonomously on the road. You can see the full-featured picture about the environmental recognition and the car-to-car communication. And, you know, in the future, all the findings the car recognizes will be pushed into the cloud, you know, for automated map updates. And again, here we have another vector, you know, where hackers can modify, I think, knowledge bases and databases by injecting wrong objects, and the goal is, you know, to create damages. So, in context of the robotic drive, we have alliance now with BMW and Daimler, and for assuring the functional safety and the operational safety of autonomous drive, we have to have a closed loop and, you know, to have at least a robustness, you know, for, you know, functional safety. We need millions of driven miles. And for that, you know, we create a so-called Robotic Drive initiative. We have a petabyte data storage cloud managed system, and we put all our trace data coming from the cars into the database, and by means of artificial intelligence and machine learning, we are able, you know, to label data and to create many outcomes, assisting us, you know, to use for modeling of sensor models, virtual hyper-realistic environments, and closed-loop simulations prior at least going with some functionality into the car. Yeah? And this is also, I think, under the scope of cybersecurity, a very important topic, because here we have ingest stations to ingest all the outcome or all the captured data into the car, and we have to make sure the data is valid and not manipulated, because otherwise it could affect us in a malfunction. Within the connected mobility, we have 5 pillars. We have telematics, smart mobility, platform, cloud, and data analytics. One of the very particular topics are, for example, over-the-air update systems. Yeah, as I said before, when I started, I think, introduction, the old car has no ability, you know, to do over-the-air updates. I think it's a static system, and by, for example, cars like Teslas and OEMs and car manufacturers, we know already they are issuing updates, instant updates to update their services, their functionality, to at least improve functional safety and functionality. We have smart mobility. We have a platform, and within the platform we need also to care about cybersecurity. The same for cloud and data analytics. So I forgot to mention, if we issue over-the-air update, we have to secure the transportation channel as well. We have to guarantee, you know, the images to be inserted, to be deployed to the vehicles. They need to be secured. And when the data update comes to the car, you know, we have to validate if it's still safe. So in the personal mobility, I think there are now many different trends. We have rental cars, we have assets to share, cars with drivers, we have insurances. I mentioned already usage-based insurances. For example, you can subscribe 5 days insurance, you know, and automatically, I think the tracking will happen. You know, we have to be integrated into city infrastructure, you know, payment services, parking, ride-hailing, sharing, and also connectivity to financial industry for payments, for financing, and so on. In the sector of cybersecurity for mobility, in the last years we have recognized the threat landscape is really emerging, and we are getting always more attacks. In particular, in the past, we could recognize keyless entries, you know, to steal cars, to get access to the cars, and so on. But as well, I think an emerging, growing threat market is infotainment and mobile apps, and as well, you know, the connected cloud security and safety, because it also can happen, can influence safety and security at this point. And there are many different access points, you know, where security and safety can be compromised. Firmware upgrades, I talked about it, malicious software, you know, actuators, certificate management, back-end services, man-in-the-middle attack, and so on. In the past, we talked at least about some very prominent problems, but at least they caused only some financial damage. But now, if we do a so-called prediction into the future, you know, we are at the next generation, autonomous driving, assisted driving, driving assistance, and so on. And I think the damage could be much bigger, because life of the drivers or the people on board is in danger. So automotive industry figures very much cars on the road connected in the near future, you know, a million lines of codes, plenty of gigabytes for operational data, and also multimedia services. And I think this is really to be considered for research and for further investment into security. And at the OEMs, safety, security for their vehicles is a very important issue. Use cases are, for example, teleoperation. We have in sync with our OEMs regarding teleoperated driving, fallback solution for auto driving, autonomous driving, and in conjunction with our telco operators, I think 5G is quite interesting, because it allows low latency and high bandwidth for remote control of vehicles of any type. It's not only cars, it's buses, commuter buses, trains, and so on. I am really glad later to share with you some more deep dive here. The same functionality could be used and can be used, for example, for logistics hubs, so that a truck driver can walk away and all the maneuvering at the logistic yard could be performed automatically by infrastructure-driven technology or by teleoperation. But again, here we have to spend really a severe focus on cybersecurity, because we have here the full set: communication technology, localization, cloud technology, onboard technology, and I think the problem is here multidimensional. So I would like to thank you for your attention here, and you know, if there are any questions, I would be really glad to answer maybe a few right now, or at least I will be here until end of the sessions and also tomorrow, and we can discuss in detail this kind of requirements coming out of the mobility landscape. Thank you very much.